Picture this. You pull into a charging stop the same way you'd pull into a gas station. You plug in. You check a message on your phone, maybe stretch your legs for a minute, and before you've even finished that short break, your car is already carrying enough energy to drive past 600 miles. Not as a concept, not as a stage demo behind glass at a tech expo. As a real car, built on a real production line, sold to real customers right now. Here's the part that should stop you. The reason this car can do that has almost nothing to do with a bigger battery. It has to do with the fact that in this car, there is no separate battery at all, not in the way you're picturing one. The floor you'd be sitting above isn't sitting on top of a battery pack. The floor is the battery pack. The structure that holds the car together, the very skeleton of the vehicle, is doing double duty as the thing that stores the energy that moves it. That single decision is the reason this car charges the way it does, drives the way it does, and survives a crash the way it does. And once you understand how a company got there, you'll understand why almost nobody else in the auto industry can copy it overnight. The company behind this is BYD, and if you spent any time reading about electric cars in the last year, you've probably already heard the name. What you may not know is where it came from, because that origin story is not just a fun bit of trivia. It is the entire reason this technology exists at all. This did not come out of a famous design studio in Munich or a research lab in Silicon Valley. It came out of a small rented room in Shenzhen, China in 1995, where a chemist named Wang Chuanfu set up shop with a plan to build rechargeable batteries for mobile phones. At the time, phones were exploding in popularity across the world, and somebody had to make the batteries that powered them. Wang saw that opportunity and built a company around it from almost nothing. What made BYD different from other battery makers wasn't luck. It was obsession. They studied every layer of a battery cell, every chemical reaction happening inside it, every single way a battery could fail. They learned how to build batteries that were reliable and cheap at the same time, which is a much harder combination to pull off than it sounds. That deep, almost stubborn understanding of battery chemistry didn't disappear when the company decided to start building cars in the early 2000s. It became the foundation of everything that followed. Here's the part that explains so much of what came later. Like when BYD entered the car business, they didn't think like a car company that needed to go buy batteries from somebody else. They thought like a battery company that happened to be building a vehicle around their own cells. That sounds like a small distinction, but it changes everything about how you design a car. Most automakers treat the battery as a part. You buy it, you bolt it under the floor, and you engineer the rest of the car to work around it, the same way you'd build a room around a couch that's too heavy to move. BYD never thought about it that way. To them, the battery wasn't a part you sourced. It was the thing they understood better than anyone else in the building, and they intended to build everything else around that strength. That mindset led to a bet back around 2020 that a lot of the rest of the industry quietly thought was a mistake. BYD decided to put its full weight behind a battery chemistry called lithium iron phosphate, often shortened to LFP. Most competitors had been moving away from it because LFP simply can't pack in as much energy per kilogram as some of the newer, more exotic battery chemistries on the market. On paper, it looked like the cheaper, weaker option, the kind of battery you settle for instead of the kind you brag about. BYD looked at the same chemistry and saw something different. They saw a battery that was inherently more stable, that lasted longer through repeated charging cycles, and that could be manufactured at a much lower cost. Instead of accepting its energy limits as a fixed problem, they decided to redesign the physical shape of the cell itself. They made the individual cells long, thin, and flat, like actual blades, and packed them edge to edge with almost no wasted space between them, no bulky module casings, no extra boxes wrapped around clusters of cells the way older battery packs were built. Just dense, efficient rows of flat cells laid out like the floorboards of a house. To prove how tough this design really was, BYD staged something almost theatrical. They drove a fully loaded 46-ton truck directly over a blade battery pack sitting on the ground. The pack didn't catch fire. It didn't leak. It barely showed a dent. Wang Chuanfu said at the time that his goal was to remove the words spontaneous combustion from the conversation around electric cars entirely. That kind of confidence doesn't come from a marketing department. It comes from a company that built every single layer of that battery themselves and knows exactly how it behaves under stress. The blade battery was a real breakthrough, and it's still in use across BYD's lineup today, but here's the detail that matters for everything that comes next. At that stage, the blade battery was still at its core a separate unit, a flat box you build, then bolt into a car. The next leap, the one that actually rewrites the blueprint for what an electric car even is, was still a few years away. And to understand why that next step landed so hard, you first have to be honest about the problems that have quietly been holding electric vehicles back this whole time, the ones that rarely make it into the commercials. Start with charging time, because this is the one almost every EV owner runs into eventually. The ads love the phrase fast charging. The reality at most public charging stations is closer to 30 or 40 minutes for a meaningful top-up. That's not a quick stop. That's a full meal, a long phone call, or half a chapter of an audiobook. If you grew up spending 5 minutes at a gas pump and driving off, that wait adds real friction to your life. It changes how you plan a road trip. It adds a layer of mental math that a gasoline car simply never asks of you. Then there's range, and the conditions attached to it that almost nobody mentions out loud. Most affordable electric cars on the market today claim somewhere between 250 and 300 miles on a full charge, and that number assumes close to ideal conditions. Mild weather, steady highway speed. Climate control not working too hard. Take that same car into a real winter and the range can drop by 30% or more. Cold temperatures slow down the chemical reactions inside a battery, and on top of that, the car has to burn its own energy just to keep the battery warm enough to function properly. That same cold weather also slows down charging speed. Drivers have pulled up to fast chargers in January and watched the power delivery crawl at a fraction of what it managed back in August, sitting there in the cold while the percentage climbs painfully slowly. But here's the part that almost never shows up in a sales brochure, and it's the real root of nearly every other complaint. In the overwhelming majority of electric vehicles on the road today, the battery is a separate, heavy box strapped underneath the floor of the car. It does exactly one job. It stores energy. It contributes nothing to the structural strength of the vehicle. Engineers have to build the entire car around that box, the same way you'd build a room around a piece of furniture that simply cannot be moved. The battery goes in first, and everything else gets engineered around it. That layout creates a chain reaction of problems. The battery box adds weight that does absolutely nothing for the car's rigidity or its safety in a crash. The heavier the car gets, the more energy it needs just to move itself down the road, which means engineers respond by adding an even bigger battery, which adds even more weight. It's a loop that keeps working against itself, and it's a challenge every electric vehicle maker on the planet is wrestling with right now, whether they admit it publicly or not. BYD looked at this entire list of problems and made a decision that a lot of engineers would call reckless. They decided that small improvements to the existing design weren't going to be enough. The whole layout had to change, starting with a question almost nobody else in the industry had seriously asked out loud. What if the battery and the body of the car weren't two separate things? What if they were the same object doing two jobs at once? That question is exactly what led to BYD's structural battery approach, something the company calls cell-to-body. Instead of placing a sealed battery box underneath the floor of the car, the top surface of the battery cells themselves becomes the actual floor of the passenger cabin. You're not sitting on top of a battery anymore. You are sitting on the battery. The cells become part of the skeleton of the vehicle, spreading load and impact force across the frame the same way steel beams spread weight through the frame of a building. Think about the difference this way. The old approach is like strapping a heavy backpack to the underside of the car. It comes along for the ride. It adds weight, and the rest of the car has to compensate for that dead mass. The new approach is closer to how your own skeleton works inside your body. Your bones aren't just sitting there doing nothing. They hold you upright, they absorb impact, and they make every movement you take possible in the first place. BYD essentially gave the car a skeleton built out of its own energy source. The results of that shift show up everywhere you look. Using standard industry torsion tests, BYD has reported that this structural approach increases the body's stiffness by somewhere around 70% compared with the company's previous design. That level of rigidity puts these cars in a category usually reserved for luxury vehicles that cost several times as much, vehicles that rely on exotic materials and expensive engineering tricks to hit similar numbers. BYD got there without any of that, just by rethinking where the battery physically lives inside the car. The efficiency gains are just as significant, and they come from a very simple source. By removing the separate casing that used to wrap around the battery box, a much larger share of the total space inside that structure is now actual energy storing cells, rather than packaging, wiring channels, and cooling shrouds. In older battery designs, a meaningful chunk of the available space was eaten up by protective layers that did nothing but protect. Eliminating most of those layers means the same physical footprint can now hold dramatically more usable energy. That's a big part of why BYD's newest flagship models can claim range figures well past 600 miles under China's CLTC testing cycle, which tends to report higher numbers than the kind of real-world testing American drivers are used to seeing from EPA ratings. Even accounting for that gap, the underlying efficiency gain is real, and it shows up in everyday driving range too, not just on paper. It also means the car weighs less for the same amount of stored energy, because all that extra packaging weight has simply been removed. Less weight means more efficiency. More efficiency means more range from the same battery. And because the battery is now structurally part of the car, the whole vehicle handles better too. The added stiffness improves cornering, reduces vibration through the cabin, and makes the car feel more solid and planted at speed. The kind of feeling usually associated with cars that cost twice as much. All of that on its own would already be a serious leap forward. But none of it is the number that made the rest of the auto industry go quiet. That came in March of 2025, when BYD held a launch event to unveil what it called the Super E platform. The crowd in the room was following along, clearly impressed but not yet shocked. Then BYD put a number on the screen that the rest of the industry is still reacting to. Using a new megawatt-class charging system, BYD said its newest vehicles could add roughly 250 miles of range in about 5 minutes. That's a full megawatt of charging power flowing into a single car, more than double what most of the fastest public chargers in the world could deliver at the time. Let that sit for a second. 250 miles, 5 minutes. That's not a quick top-up to nurse you to the next stop. That's a full trip's worth of range, delivered in less time than it takes most people to scroll through their phone after waking up in the morning. For drivers who regularly cover long distances, that single number erases most of what's left of the charging time argument against electric vehicles. Here's where the story gets even more interesting, because BYD didn't stop there. About a year later, in early 2026, the company went further still, unveiling a second generation of its Blade battery alongside an upgraded charging network it calls flash charging. This new system pushes peak charging power up to 1,500 kilowatts, delivered through a high-voltage architecture built specifically to handle that kind of load without melting anything in the process. According to BYD, a car equipped with this technology can go from 10% charge to 70% in about 5 minutes, and all the way up to 97% in roughly 9 minutes. The company intentionally leaves that last small sliver of charge available, so the car's regenerative braking system still has somewhere to put energy when you're driving again, rather than chasing a meaningless final few percent. Now for the detail that actually matters most to anyone who lives somewhere with a real winter. Because cold weather has always been the quiet killer of electric vehicle enthusiasm, BYD ran a public test at minus 30 degrees Celsius, roughly minus 22 Fahrenheit, the kind of cold that can make a door handle feel like it's about to snap off in your hand. Under those brutal conditions, the company reported that charging from 20% up to 97% took only about 3 minutes longer than it does at room temperature. 3 minutes, not 30, not 50. 3 extra minutes in conditions that would leave most current electric vehicles charging at a fraction of their normal speed, if they'd even let you charge that fast at all. That kind of cold weather performance comes from thermal management built directly into the redesigned battery and the cell-to-body structure surrounding it, keeping the cells inside their ideal operating temperature, even when the outside air is doing its best to fight against that. The flagship vehicle showing off this entire package right now is the Yangwang U7, BYD's full-size luxury sedan built under its premium Yangwang brand. With its largest battery option, BYD rates the U7 at over 1,000 kilometers of range under Chinese testing conditions, somewhere above 600 miles. Real-world range, especially outside the milder CLTC test cycle, will land lower than that headline number, the same way it does for nearly every range claim from any manufacturer anywhere in the world. But even adjusted downward, the number that's left over is genuinely exceptional by any standard currently on sale. A fast car with a fast battery is only useful if there's somewhere to actually charge it at that speed, and BYD had clearly been thinking about that problem long before any of these cars reached a showroom floor. Charging at 1,500 kilowatts is not something you simply plug into an ordinary power line running down a street. That kind of output demands serious electrical infrastructure, and if thousands of stations tried to pull that much power directly from the grid at the same moment, it would put enormous strain on the entire local power system. That's one of the biggest practical roadblocks standing between ultra-fast charging and everyday use, and BYD's solution to it is almost disarmingly simple. Each flash charging station comes with its own energy storage system built directly into it. The station draws power from the grid slowly and steadily throughout the day, at a pace the local grid can handle without strain, and stores that energy internally. When your car pulls up, the station releases all of that stored energy into your battery at full speed, without ever spiking the demand it places on the surrounding grid. Picture it like filling a water tower gradually all day long, then opening the tap completely the moment somebody actually shows up needing water. The pressure is already there because the work was done well in advance. By the time this second generation system was unveiled in 2026, BYD already had more than 4,000 of these stations built and running across China, a number it had been quietly growing since the first version of the network launched the year before. The company's stated target is 20,000 stations across the country by the end of 2026. That's not a hopeful line on a slide with a date attached to it that nobody expects to hit. That's infrastructure that was already being poured into the ground, while the next generation of cars was still being engineered behind closed doors. The chicken and egg problem that has crippled so many charging networks, where nobody builds chargers because there are no compatible cars, and nobody buys the cars because there's nowhere to charge them, simply doesn't apply here, because BYD has been building both sides of that equation at the exact same time. The scale of BYD as a company is worth pausing on, because it's what turns this from an impressive announcement into something with real lasting momentum behind it. In 2025, BYD sold more than 4.5 million new energy vehicles worldwide, a mix of fully electric and plug-in hybrid models that made it the best-selling electric vehicle brand on the planet that year. Not one type of car, a full range, stretching from compact city cars priced well under $15,000 all the way up to six-figure performance flagships. And the same underlying structural battery philosophy runs across almost the entire lineup. Cell-to-body construction is not a showcase feature reserved for one expensive halo model sitting alone on a stage. It's a platform, and platforms spread. The same structural concept scales directly into buses, delivery trucks, and even stationary energy storage systems used to back up buildings and electrical grids. The physics behind it works just as well in something 3 times the size of a sedan as it does in the sedan itself. It's worth being honest about where this technology actually exists right now too, because that matters for how you should think about it. These vehicles in this charging network are built first and foremost for the Chinese market, where BYD already sells the overwhelming majority of its cars. The company has been expanding aggressively into Europe, Latin America, and parts of Southeast Asia, and it has already started talking publicly about bringing both its newest vehicles and its flash charging network to European roads. BYD does not currently sell passenger cars in the United States, and there's no clear timeline for when or if that changes given the current trade and tariff environment. So if you're watching this from somewhere in North America, this is a story about what's possible right now somewhere else in the world, and about how fast the rest of the global auto industry is now being forced to respond to it. There's a bigger strategic reason this is happening in China specifically, and it's worth understanding because it explains why BYD is moving with this kind of urgency, instead of rolling out the technology slowly over a decade. China imports the large majority of the oil it consumes, shipped across long ocean routes that pass through narrow, contested waterways the country doesn't fully control. Every barrel of that oil represents a strategic vulnerability, a dependency on foreign supply chains that Chinese leadership has openly said it wants to reduce. Electrifying the country's vehicle fleet isn't just a climate policy or a consumer convenience story from Beijing's point of view. It's treated as a matter of long-term energy security, the same way a country might think about food supply or domestic energy production. That's part of why the Chinese government has poured years of subsidies, infrastructure spending, and favorable regulation into the electric vehicle industry, and it's part of why a company like BYD can move this fast without waiting around for the rest of the market to catch up first. When BYD's own chairman talks about this technology in public, he frames it as something the country needs, not just something customers might enjoy. That kind of backing changes how quickly a technology can go from a lab demonstration to 20,000 charging stations actually being built. That pace is also reshaping who wins and who loses inside the auto industry, and the losses are already visible in the sales numbers. Established automakers that built their reputations on gasoline engines, companies like Volkswagen, Nissan, and several other long-standing brands, have watched their market share inside China shrink steadily over the past few years, as buyers shift toward domestic electric and hybrid options. Smaller Chinese EV startups are feeling pressure too, forced to either match BYD's pace of innovation or get squeezed out by a competitor that can outbuild and out-engineer almost anyone else in the category. Tesla, long seen as the default leader in this space, now finds itself in a genuine fight for the global EV sales crown rather than a comfortable lead, and BYD's charging breakthrough only adds more weight to that pressure. None of this means the rest of the industry is finished. It means the bar for what counts as a competitive electric vehicle just got raised dramatically, and every company building cars right now has to decide how quickly it can climb up to meet it. Every major automaker building electric vehicles today is absolutely doing that math, whether they're saying so publicly or not. Several have their own structural battery concepts somewhere in development. But the specific combination BYD has put together, cell-to-body construction, charging speeds measured in single-digit minutes, genuinely strong cold weather performance, and a charging network actually built out at scale to support all of it in one coordinated package, is a combination nobody else has matched in a production vehicle yet. The target everyone else is chasing just moved, and it moved a long way in a very short amount of time. So what does all of this actually mean if you're someone thinking about an electric vehicle in the next year or two, wherever you happen to live? It means the entire conversation around electric cars just shifted, and it didn't shift gradually. Once 5-minute charging exists in a real, purchasable car, a 30-minute charging stop starts to feel the way a dial-up internet connection feels today. It still technically works, but something fundamentally better clearly exists now, and there's no pretending otherwise once you've seen it. The 3 biggest reasons people hesitate before switching to an electric car have always been charging time, range anxiety, and cold weather reliability. What BYD has built addresses all 3 at once, in the same vehicle, using the same underlying technology. 5-minute charging removes most of the time argument. Range well past 600 miles under favorable conditions removes most of the range argument. 3 extra minutes of charging time at minus 30 degrees removes most of the winter reliability argument. When all three of those long-standing objections fall away together in the same car, that's not an incremental improvement. That's the kind of shift that tends to redraw an entire market over just a few years. There's a long-term cost story buried inside this too, one that matters even if you never personally buy one of these specific cars. Fewer separate parts. Less material wasted on packaging that serves no purpose beyond protection. More of the available physical space actually being used to store usable energy. A design that's simpler to manufacture tends to become a design that's cheaper to manufacture over time, and cheaper to manufacture eventually means more accessible to more buyers at lower price points. The technology that lives in a flagship luxury sedan today has a fairly clear path towards showing up in far more affordable vehicles a few years from now. That's how almost every major automotive technology has ever spread throughout history. It starts where the profit margins are highest, on the most expensive vehicles, and it works its way downward as the manufacturing process matures and costs come down. There's also a safety dimension here that's easy to overlook in all the excitement about charging speed, but it matters just as much. A car body that's roughly 70% stiffer than before doesn't just feel more solid when you're driving it. It distributes the energy of a collision more evenly across the entire structure, rather than concentrating that force in just one or two weak points. Because the battery is now woven directly into that structure instead of sitting separately beneath it, the battery is protected by the very framework it's helping to build. In older designs, a severe impact that breaches the outer battery box can create serious problems fast. In a cell-to-body design, the battery itself is part of what makes that outer shell genuinely harder to breach in the first place. The electric vehicle was always supposed to eventually reach a point where switching away from gasoline felt like an obvious decision rather than a frustrating compromise you talked yourself into. Shorter range than you'd like, charging stops that eat into your day, performance that falls apart the moment winter shows up. Those were never permanent laws of physics. They were temporary limitations, waiting for the right combination of engineering to finally catch up with the promise. What BYD has shown over the past 2 years is a strong, credible sign that the engineering has genuinely caught up. At least for this one company, in this one moment. The rest of the global auto industry now has some serious running to do, and every single one of them knows it. That's the full arc of this story. A company that started out making batteries for mobile phones in a single rented room has, 3 decades later, redefined what an electric car fundamentally is. Not by stuffing in a bigger battery and hoping that solves everything, by making the battery the car itself, the floor you sit above, and the frame that holds everything together, instead of a heavy box quietly riding along underneath, doing one job and getting in the way of everything else. The next time someone tells you electric cars still aren't ready for real life, you'll know there's already a very different answer to that, sitting on a production line in Shenzhen, charging in less time than it takes to finish a cup of coffee.